Hello everyone, and welcome back to our course Python for Data Science. In this lecture we will discuss about sequence data operations in Python. In the previous lecture, we explored what sequence data types are and how to create them, such as strings, lists, tuples, dictionaries, sets, and ranges. In today's lecture, we will discuss about performing various operations on sequence data types. One crucial operation we'll cover today is indexing, which allows us to access specific elements within a sequence. Indexing in Python is a powerful concept that allows you to access individual elements or substrings within a sequence data type, such as strings, lists, or tuples. It provides a convenient way to manipulate and work with specific parts of these sequences. In this part, we'll focus on indexing in the context of string data sequences, including accessing individual characters and substrings. In Python, strings are sequences of characters, and each character within a string has a corresponding index or position. Indexing starts from 0, so the first character in a string has an index of 0, the second character has an index of 1, and so on. To access a single character in the string, you can use the square bracket notation along with the index position of the desired character. In this example, greeting 0 returns h, because it accesses the character at index 0, the first character, and greeting 7 returns w because it accesses the character at index 7, the 8th character. Python also supports negative indexing, which allows you to access characters from the end of the string. The index -1 refers to the last character and the index -2 refers to the second to last character, and so on. Indexing and slicing are powerful techniques in Python that allow you to manipulate strings with ease. They enable you to access individual characters, extract substrings, and perform various operations on specific parts of a string. Understanding indexing is crucial when working with strings and other sequence data types in Python, as it provides a flexible and efficient way to interact with and manipulate data. Next, we will discuss about indexing of list sequence data. In Python, indexing works the same way for lists as it does for strings. You can use the square bracket notation along with the index position to access individual elements within a list. Lists in Python are ordered collections of items, and each item in the list has a corresponding index. Indexing starts from 0, so the first item in the list has an index of 0, the second item has an index of 1, and so on. To access an individual item in the list, you can use its index. In this example, fruits 0 returns apple because it accesses the item at index 0, the first item, and the fruits 3 returns date because it accesses the item at index 3, the fourth item. Like strings, Python also supports negative indexing for lists, which allows you to access items from the end of the list. In this example, the fruits -1 returns elderberry because it accesses the last item in the list, and the fruits -3 returns cherry because it accesses the third item from the end of the list. Indexing also allows you to modify individual items in a list by assigning a new value to a specific index. In this example, we replaced the item at index 2, originally cherry, with orange. However, it's important to note that attempting to access an index that is out of range for the list will result in an index error. Next, we will discuss about indexing in tuples, since tuples are immutable ordered sequences of elements. Like strings and lists, you can access individual elements within a tuple using their index positions. In this example, fruits 0 returns apple because it accesses the item at index 0, the first item, and the fruits 3 returns date because it accesses the item at index 3, the fourth item. However, unlike lists, tuples are immutable, which means you cannot modify individual elements within a tuple. Attempting to assign a new value to an index position in a tuple will result in a type error. If you want to modify the elements of a tuple, you need to create a new tuple with the desired changes. Next, we will discuss about indexing of sets. The sets in Python are unordered collections of unique elements. Unlike sequences like strings, lists, and tuples, sets do not maintain a specific order of elements, and they do not support indexing in the same way as sequences. In Python, sets do not support indexing or accessing elements by their position because they are inherently unordered data structures. Each element in a set is unique, and the order of elements is not guaranteed to be consistent across different operations or iterations. However, you can still access and iterate over the elements in a set using loops or other methods. For example, in this example we print out the elements of the fruit set, but the order in which they are printed may vary each time you run the code because sets are unordered. If you need to access elements in a specific order, you can convert the set to a list or tuple using the list or tuple functions, respectively. These conversions will preserve the elements but not the order, as sets are unordered by nature. In summary, while sets in Python do not support indexing or accessing elements by their position, you can still iterate over the elements, perform set operations, and convert sets to other data structures like lists or tuples if you need to access elements in a specific order. Next, we will discuss about indexing of dictionaries. In Python, dictionaries are unordered collections of key-value pairs, where each key is unique and paired with a corresponding value. While dictionaries do not support indexing in the same way as sequences like strings, lists, and tuples, you can access the values in a dictionary using their associated keys. To access the value associated with a specific key in the dictionary, you can use the square bracket notation with the key. In this example, person name returns the value Alice because it accesses the value associated with the key name, and person age returns the value 25 because it accesses the value associated with the key age. If you try to access a key that does not exist in the dictionary, Python will raise a key error. While dictionaries do not support indexing like sequences, you can iterate over the keys or key-value pairs using loops or methods like keys, values, and items. In summary, while dictionaries in Python do not support indexing like sequences, you can access the values in a dictionary using their associated keys. This is done using the square bracket notation or the get method. Additionally, you can iterate over the keys, values, or key-value pairs in a dictionary using various methods and loops. Next, we will discuss about range. In Python, the range object represents an immutable sequence of numbers. It is commonly used in loops and for generating sequences of numbers with specific patterns. While range objects are not technically containers like lists or tuples, they still support a form of indexing that allows you to access individual elements within the sequence. Here's an example of creating a range object. This creates a range from 0 to 9. You can access individual elements within the range object using indexing with square brackets, similar to how you would index a list or tuple. In the above example, numbers 0 returns 0, the first element, and the numbers 4 returns 4, the fifth element. Keep in mind that indexing in range objects starts from 0, just like lists and tuples. Attempting to access an index that is out of range will result in an index error. Like other sequence types, range objects also support negative indexing, which allows you to access elements from the end of the sequence. It's important to note that while you can access individual elements of a range object using indexing, the range objects are designed to be memory-efficient representations of sequences of numbers. In summary, while range objects in Python are not containers like lists or tuples, they still support indexing to access individual elements within the sequence. This can be useful for certain operations or when working with specific elements of a range, but range objects are often used in conjunction with loops or converted to other data structures for more complex operations. So, in summary, the key points regarding indexing in sequential and non-sequential data types in Python are like: for sequential data types, strings, lists, tuples, ranges indexing is supported and allows accessing individual elements based on their position or index. Indexes start from 0 for the first element. Positive indexes are used to access elements from the beginning, 0, 1, 2. Negative indexes are used to access elements from the end, -1 for the last element, -2 for the second to last, and so on. Indexing can be used to retrieve, modify, for mutable types like lists. In the non-sequential data types sets, indexing is not supported because sets are unordered collections of unique elements with no defined order or positions. Dictionaries, while dictionaries are non-sequential, you can access values using their associated keys instead of indexes. Keys act as a form of indexing or lookup mechanism to retrieve values in dictionaries. Keys must be unique within a dictionary. You cannot use numerical indexes to access values in a dictionary directly. In summary, indexing is a fundamental operation for sequential data types in Python, allowing you to access, modify, and manipulate elements based on their positions. However, for non-sequential data types like sets, indexing is not applicable due to their unordered nature. Dictionaries, although non-sequential, provide a way to access values using keys as a form of indexing or lookup mechanism. So, in this course we have covered indexing on sequential and non-sequential data type. In next lecture we will discuss about slicing and methods in Python. Thank you for joining us in this lecture. We hope that you have found this course informative. Please hit the like button and subscribe to our channel to stay updated for upcoming videos. Your support means a lot and motivates us to create more educational resources for you. Stay tuned for the next lecture, where we'll continue our journey through Python's data science course. Thank you for watching.